Okay. The reason is one chapter content, as I said earlier. Chapter 4, we only have one section, and we also skip one section on chapter 5. So, you know, these two chapters combined together actually is pretty much one chapter section, okay? One chapter content for this test, all right? So I saw some people already almost ready to do the test, which is good. Let's see, we're gonna go ahead and share you the application screen, which is a little bit easier to write for me in this case, all right? So I just open the this one right here, test 3 review in here, okay? So the first one, this is for 4.1, provide an appropriate response, state whether the variable is discrete or continuous. So we need to know what is discrete, what is continuous. So sometimes we say discrete is something you can count, or it's kind of countable, okay? And continuous, so this usually just, you know, as 0, 1, 2, 3, something you can count, okay? For the continuous is kind of something, I say something you can measure, all right? And this one can have a decimal point, like I said, 0.5678 and on, depends on what kind of instrument you use. So this one continuous can have a decimal point. When we count something like count the number of the people, we don't count a half a person, right? So this countable always has an integer in here, okay? All right, so let's look at the first one, the height of a person, the height of a player on a basketball team. And the height, sometimes people say, well, the height of a person actually, believe or not, this one is continuous, right? Because we can have a 6 feet, 2 inches and something like that, all right? We don't just say you have a 6 feet, 7 feet, or 5 feet. We always have inches as well, okay? So this one is a continuous, all right? The cost of a statistic book. Well, the cost we usually kind of run to cents, all right? So actually this one is discrete because we cannot break down into, you know, the cost we usually just by, you know, rounded by cent, okay? Number of appeals. All right, so number of appeals is something you can count, okay? So this one will be a discrete in here. So that is section 4.1, which you kind of need to know what is continuous, what is a discrete, okay? Number 4, the random variable represent X is the number of the car per household in the town of 1,000 household in here. Find the probability of a random select household that have at least one car. So what does at least one car mean? That means one or more, right? So at least one car will be 1, 2, 3, or 4. One thing is you can go to add all of these together, the probability of at least, okay, one car. All right, you can either use the complementary or you can use the direct way. So I'm gonna use the complementary, otherwise I will gonna have to add all of this together, seems a lot. So we're gonna have probability of 1 minus less than 1 car, less than 1 car, which is 0, right? So 1 minus less than 1 car is 125 divided by 1,000. All right, so that's 1 minus this divided by 1,000 is 0.125. So we're gonna have a 0.875, which is B in here, okay? So that is how we do this type of question. If you don't want to do this way, you can go to add all of this together, 428 plus 256 plus 108 plus 83 divided by 1,000. It should give you the same number, all right? But I just thought like this one, you have to add a lot of more number. than the previous one, right? So I just thought this one is a little bit easier. But either way will be good, okay? As long as you do the calculation right, it really doesn't matter which way you do. But personally, I like to choose a little bit easy way, okay? Any questions so far? If you have any question, you can talk or you can type it on the chat section, okay? I will check the chat section every once in a while. Okay, number 5, the random variable X represents the number of the cars per household in the town of 1,000. This is pretty similar, right? This time you want to select a random variable, select a random household that has between 1 and 3 cars inclusive. So I will only need to pick these 3 in here, okay? So the probability of between 1 to 3 is 428 plus 256 and then plus 108 divided by 1,000. Okay, because it does telling you 1,000 here. If you didn't tell you 1,000, now you're gonna have to add all of this together, you know, to get a total in here. Okay, so if you go to do this one, this will be D 0.972 in here. All right, so that is the discrete probability in this case. Number 6, determine the probability distribution for the missing value in here. Well, one thing is we have to know the probability is always positive, okay? Greater than or equal to 0 or less than or equal to 1. That is the probability character. The second one here is the probability add up together always equal to 1. So in one table, the sum of all the probability must be equal to 1. So that means 0.16 plus 0.04, 0.19, 0.14 plus this unknown, this sum, the sum of the probability should equal to 1. So I will go to add all of these together in here. And this will give you 0.53 plus this unknown, right? So this unknown, you minus 0.53 on both sides, that will give you 0.47 in here, okay? So that's using this property, the sum of all of them together should be equal to 1. And you can do the algebra calculation, which should be straightforward in here. So you just need to understand the concept in this case, okay? All right, number 7 is the expected value in here. If 1,000 tickets are sold at $2 each, the ticket will randomly select and the winner will receive a color television value at $387. What is the expected value? So the expected value, that means every $2 you purchase the ticket, right? How much will you donate? I usually just like to use donate better than the lost, okay? You feel much better when you donate something, right? So when you buy a lottery ticket, you actually help, you know, whatever the state or the, you know, whoever issued the ticket, you donate something to the organization, okay? Because they don't use $2 to award all the you know, the prize to people, right? So we're gonna have to, using this is probability, set up the table. And this table using the gain, number of the gain, and then the probability. So we're gonna have the expected value actually is equal to the mean, right? And the mean for the discrete probability here is the sigma of x times p, okay? If you go to look at the variable, if you look at the formula sheet in chapter 4, you have a discrete probability. Again, you can use all these formula sheet for the test, right? And that is the bin of the discrete random variable mu is equal to this one, and the expected value is the same thing as the expected value is the same as the bin, okay, as the bin in here. All right, so that is the one we use in here. But if you win 387 price, you have to purchase $2 ticket. Okay, so the value you gain here actually is 385. So that's why we say we're using the gain in here. And since there's only one ticket here, so the probability you're gonna win this prize is 1 out of 1,000 because you have a total 1,000 ticket. For those people who did not win the prize, they're gonna donate $2. So we use the -2. That means that is the gain. The gain is negative. That means it's a loss, right? And we usually no one want to lose. So we're gonna just say you donate $2. What is the probability you're gonna donate $2? There's a good chance 999 out of 1,000 you're gonna donate $2 because there's only one prize in here. Okay, so sometimes people say, you know, you have a better chance to get hit by lightning than win like a jackpot, you know, that kind of thing, because the probability is so small, right? Okay, so the expected value is equal to sigma x times p. This one we have to multiply before you add them together. So we're gonna have a 385 times the probability is 1 out of 1,000 plus this one will be -2 times probability is 999 over 1,000. Okay, how do you calculate this one right here? You can just multiply the numerator, and this is -2. Okay, that's -2. So this should be -2 times 999. All right, so this one we are giving you a negative value in here. This will be -1.61. Okay, this will give you a -1.61. And what does that mean in here? That means every $2 every ticket, okay, every ticket you purchase, okay, every ticket is one purchase, okay, you actually what? You lose, if you want to say lose, or you can say donate, okay, $1.61. So that means this organization only what? Only use 39 cents for every ticket to use for the price, you know, for every ticket purchase. They only use 39 cents for every $2 to award the people in here. So this one, they keep majority of the money in here. They keep $1.61. Okay, that is this kind of called expected value. Any questions? All right, next one right here is pretty similar, except this time you have more prices, okay? When you have more prices, you just have to set up a little bit more. The procedure is pretty much the same. We're using the gain, and then we're using the probability in here. So this time you have 10,000 tickets, but it costs $5 each, right? If you win a false prize, how much you get? Well, you're gonna have a 4800 minus 5, right? That is because you have to pay $5 ticket, so you have a 4795, and the probability of winning the false prize is only 1, so that's 1 out of 10,000. Okay, the second prize here is 1,200. So if you win, you gain 1195. Similar, this is 1 out of 10,000. If you win a third prize, 400, you're gonna have a 395. Okay, and for those people did not win anything, now we'll just donate $5. what is the chance you're gonna donate $5? Well, totally you only have 3 prices here. So 10,000 minus 3, this will giving you 999 okay? Because you have 10,000 minus 3, so that we're giving you 9997 of the chance, over 10,000 chance. This chance you're gonna just donate $5, okay? So the expected value is equal to the mean, mu, and that's sigma x times p of x, right? So we're gonna go to multiply all of these together. So this is 4795 times 1 out of 10,000, and then plus 1195 times 1 out of 10,000, and then plus 395 times 1 out of 10,000, and then plus this one will be -5 times 9997 over 10,000. Since they all have a same denominator, right? So I can just add and subtract the numerator together and then divide by 10,000. Okay, if you go to get this one, this will giving you -4.36. All right. So what does that mean in here? That means every ticket you purchase, you actually donate $4.36, or you lose this much. The owner, the organization, they only use 64 cents to award the prize. All right. So that is this type of calculation. If sometimes some company, some employer, they're trying to give people entertainment, they're not trying to make money from the people. Some of them is called fair value. Okay, so what does fair value mean? That means the expected value is equal to 0. Okay, so when you say the fair value, that means the employer, the organization did not want to make any money from the ticket. So they use all the price, to award people. That is called a fair value or fair play in here, okay? All right, so in this case, this one is not a fair play, right? Because they're trying to raise money, which is most of the time, that is the, ticket issue, trying to raise money. Okay, this is kind of come to the chapter 5 when we're trying to find a continuum probability, continuum value probability, and we're using the bell curve. Okay, that is sometimes the people in the past, ask some kind of question. If I don't have a 1 standard or 2 standard or 3 standard deviation above or below the average, how do I find a probability? On this one, we are giving you the answer in here. Okay. So we're gonna need to be able to read the table. Okay, read the table in here. So when this is a G-score. So G-score in here, remember the G-score in the middle is 0. The bell curve G-score in the middle is 0. To the right is positive. Okay, to the left is negative. All right, so we need to read this table in here, table 4, the standard normal distribution. But if you look at this table, every time you read a table is indicate area on the left hand side. So this is your key here. And how do you find the area on the right? Like this one, you want to find the area on the right. So if you want to find the area on the right, you will need to use 1 minus the area to the left. Okay, because the total area is equal to 1. All right. So when we go to read a G-score, this one G-score is negative 1.30. Negative 1.30, negative 1.3 in here, right? And then we're gonna have to go to the top. Remember this you have to read the top in here. The 0 on the negative side is at the end. Okay. On the positive side, if you go to the positive side, positive 1.30, this 0 is at the beginning. All right, so you have to be very careful because sometimes people making mistake, just didn't really read the top and down. All right, so negative 1.30, that is the number in here with 0.0968. Okay, so this is 0.0968 in here. So my area to the right here will be 1 minus 0.0968. All right, and that way we're giving you 0.9032, which is C. That will be the answer in here. Okay, so reading the table is very, very important here. All right, this one, you want to find the area under these two. Well, this is a little bit more complicated because we have an area to the left. We're gonna call this is area 1, and then we have area 2. So this total area, we're gonna have area 1 plus area 2. And then we're gonna have to go to find each area. This is area to the left, so I can just read the table. So that's negative 1.13. So that should be pretty straightforward, negative 1.13. Again, we have to read the top in here, negative 1.13. That should be right here. So that's 1.1292. Okay, so that's 0.1292. That is my area 1. Okay. How do I read my area 2? My area 2 is area to the right. So we're going to have to use 1 minus everything to the left. All right, so this area 2 is 1 minus everything to the left in here. And then we're going to go to read 2.03. Okay, so 2.03 is positive. 2.03. Right here, so that's 0.9788. All right, so we're gonna go to calculate this one right here. This will be 212, so it's 0.0212. Okay, so we're gonna plus my area 2 is 0.0212, and then you add these two together. In here, that will give you 0.1504, which is C in here. Okay, that is how you find this one right here. So like I said, this is probably the most complicated one because we have to add the two areas together, and then these two Z-score are different. Okay, so we need to read the table twice, calculate each city area, and then add them together. Okay. Any question for this one? Okay, number 10, 11, these are all reading table, okay? Number 11, we want to find the area under the bell curve between 0 and 3. So 0 and 3, that is in between, right? This area in between. Area in between, what we can do here is we're using big area. This is a big area minus this smaller area. So we have area in between, okay? So we know this area 0, since the bell curve is symmetry, right? And then the total area is 1. So when you have a Z-score is 0, this area to the left is 0.5, this to the right is 0.5. Okay, so I know this will be 0.5. So I will just need to go to read the Z-score equal to 3. If you do not know, you can read the table here. Look at it. Z-score, when this Z-score is 0, 0, 0, that is 0.5, right? So that should be pretty straightforward. When Z-score equal to 3 right here, and then we know this is 3.0 is on the top, so that's 0.9987. Okay, so we have a 0.9987 minus 0.5. So that should be 0.4987. Okay, right here. All right, so that is how you calculate the number 12 or number 11. That's in between, right? And this one is under the curve to the left, area to the left. And then G-score is 1.25. 1.25 is positive. And you want to find the area to the left. So this will be the entire area to the left in here. So this just reading the G-score 1.25 because this one corresponding to area to the left. So if I go to 1.25, 1.2 right here, 1.25, that's 0.8944. That would be the answer. Okay, 0.8944. So that is pretty straightforward, just reading the table. Okay. All right, determine whether the graph can represent a variable with a normal distribution. Now, when we say the normal will be a bell curve. Bell curve is symmetry, right? So you know the symmetry, left and right are the same. This one is called skew to the right in here because we have a long tail. This is called a long tail to the right-hand side. So this is a skewed distribution, not the normal one. Normal should be the bell curve, which is a symmetry. Okay, so no, this is not a normal one. This is skewed to the right. Okay, so that is the correct answer. The graph is skewed to the right. If you have a bell, if you have this kind of graph with tail to the left-hand side, this will be skewed to the left. Okay, this will be skewed to the left in here. All right, this kind of distribution. Okay, all right, so number 14, find the probability of the G occurring in the indicated region. Remember, in the bell curve, the area is the probability. The area is the probability in here. Okay, and sometimes we also call it a percentage. Okay, sometimes we also call it how many percent, because the total area is equal to 1, right? 1 is also called 100%. Okay, 100%, this is different than the percentile. Okay, so how many percent to the left? Okay, all right, so that is G-score negative 0.59. You can just read the table. Just make sure you go to the negative one, 0.59. So negative 0.5 right here, right? But make sure you also need to read the top. So that is 0.2776. Okay, 0.2776 in here. Okay, this one also reading the table, but it's the area to the right. So we said earlier, when you have an area to the right, we have to using 1 minus the area to the left. Okay, so 1 minus, this is G-score. Remember, that's G-score. So G-score, G equal to 1.75. So if we go to the positive one, 1.7 right here. Okay, 1.7 right here, 1.75. That is 0.9599. Okay, and then subtract this one right here. This we're giving you 0.0401 in here. Okay, so that is reading the table and you know, to match the graph. So you will need to be able to you know, read the table by the verbal expression, read the table by the you know, picture expression in here by this graph. Okay, so this one is by the number. Find the standard normal distribution of the probability when g is between negative 2.25 and 0. And these two are very similar, right? So we're gonna go ahead and do the number 17 in here. Okay, very similar in this case. We have a z-score is negative. Remember, z-score in the middle is 0. And then we have a negative 2.25. We also have a positive 1.25. And then we want to find this area in the middle, right? Area in the middle, we always using the bigger area minus the smaller area. Okay, so we're gonna call this is A1, this is A2. So the probability of the z between these two numbers, we're gonna using A1 minus A2. Okay, so everything is area to the left. So if we go to read the 1.25, now we're giving you 0.8944 minus negative 2.25. Okay, z-score is negative 2.25. Negative 2.25 is right here. It's 0.0122. Okay, so 0.122. So you can just do the calculation right here. That'll be 8822. Okay, so we do have an answer in here. The good news is multiple choice. So if you don't find any answer in here, you might need to check your calculation or you might need to check your reading, right? So that is better than just let you figure out the answer in here because, you know, at least you can check your calculation in this case, okay? Number 18, you want to find the probability of P of x is greater than 92. So that means this one, it didn't give you the z-score. Now you will need to convert it into z-score on your own, okay? So how do you convert the z-score on your own? Remember, we have a z-score formula using x bar minus mu over sigma. So that is the one you will need to use to convert this x value into the z-score, okay? So we have this is x value. We will need to convert it into z-score in here. And then this mu here is 80 is in the middle, right? And then we have a x greater than 92. So 92 is greater than is area to the right-hand side. All right, so we have a 92 minus 80 divided by sigma in here, and then you can use the calculator. Okay, 12 divided by 15. This is giving you 0.8, or you can add a 0 on your own. It's 0.80, right? Because z-score you can read up to 2 decimal points, so we can use this one in here. And then the probability of x is greater than 92 is actually z-score will be greater than 0.80. So since this is area to the right, I'm gonna have to using 1 minus the area to the left. We're gonna have to using 1 minus area to the left. But every time you read a z-score, it's always area to the left. Okay, remember this one right here. Every time you read this table, it's always area to the left. So 0.80, 0.80 is 0.7881. Okay, and then if you go to calculate this one right here, that we are giving you 0.2119, which is D in here. Okay, so this one is just giving you one more step, convert it into z-score on your own in here. All right, I think this is 5.3 already. Any questions so far?
Nope.
All right. Okay, now we're gonna move on. Next one right here. The length of pregnancy of the human are normally distributed with a mean of 268 days and a standard deviation of 15 days. Find the probability that a pregnancy lasting less than 250 days. All right, so this statistic actually is very useful, and this is based on the real data, you know, from the hospital, certain hospital. So that means the average pregnancy here is 268 days. So we usually call like approximately is 9 months, right, for a baby. But if the baby was born, if the baby is born 2 weeks before and 2 weeks after, actually is considered normal. Okay, but if this one is less than 250 days, that means it's a little bit more than 2 weeks, a little bit more than 2 weeks earlier than the average. Sometimes they call a little bit premature, right? Depends on how many days of the pregnancy in here. The days, the more premature that way. And that means the hospital gonna have to prepare something. They have to have an equipment, you know, be able to be ready to take care of the premature baby, right? So less than is area to the left hand side. So that means we're gonna look at how many percent of the baby will be born prematurely. So this is X value. We're gonna convert the X into G-score. And then we calculate this formula before, which is very easy to calculate, right? So we have a 250 minus 268 over 15, and now we're giving you negative. So that means it's below the average, right? And you can see this is negative 1.20, or you can use the calculator if you don't want to simplify. Okay. All right, so the G-score here is 1.20 for the G-score. All right, so the probability of X is less than 250 is the same thing as G-score is less than negative 0 or 1.20. Since this is the area to the left, so we only just need to read the table will be the answer. Okay, so negative 1.20, negative 1.2. 1.20, let's see where's the 0, because 0, this one is at the end, right? And now we're giving you 0.1151, 0.1151. Okay, if you want to convert it into percentages, so that is, you know, and then if you want to run to the integer in here, all right, so this is about like a 12% of the baby gonna be born prematurely. All right, so that means if you are the person, nurse worker or the doctor worker in a hospital in a delivery area, now you will need to know, get ready for that, right? 12%, around about 12% of the baby will be born prematurely that way. All right, so that is this kind of statistic in here. All right, number 20 is an airline knows for experience that the distribution of the number of the suitcase get lost each week on a certain route is approximately normal, with mu is 15.5, sigma is 3.6. What's the probability that during a given week, the airline will lose less than 20 suitcases? Well, that happened to me one time many years ago, right? So I did lose, I lost the suitcase. That was not a fun one, not a fun experience, okay? All right, so that is this one right here. The mu here is 15.5, sigma is 3.6, and 20 is on the right hand side, right? So very important, less than is area to the left hand side. Okay, so if we know the area to the left, we just need to get a G-score and read the table, that's it. So in my opinion, the probability in this chapter 5 actually is pretty straightforward. If you don't have a G-score, you just need to find a G-score and go to read the table, and that is the probability. Okay, so that in this chapter is probability is very straightforward. All right, so I have a 20 minus 10.5 divided by 3.6. Okay, so make sure if you want to use the calculator and if you want to type everything at one time, you will need a parenthesis. Okay, I'll show you, very important. So this one is 20 minus 15.5. Make sure you use the parenthesis. Oh, close that. All right, so that is 1.25. Okay, let me show you if you don't use the parenthesis, what happens. If you type this one right here, you're gonna get a 15.69, right? So that is the wrong number. Okay, so make sure you use the parenthesis. Every time when you see the two items, make sure you use the parenthesis. Otherwise, you will get a calculator error, not the formula error, but the calculator error. So that's 1.20. Okay, you will make a mistake on the calculator. That was 1.25 actually. All right, since this we know is less than is area to the left hand side. Okay, so that's area to the left. So I just need to read the table. That's it. So 1.25 is positive, right? Positive 1.2 right here. 1.25. We are giving you 0.8944. I think we read this earlier. Or 89.4%. So what's the probability that given weaker airline will lose less than 20 suitcases? Probability is a little bit close to 89% that you're gonna lose less than 20 suitcases. How about if I ask her what is the percentage that the airline will lose more than 20 suitcases in a given week? Well, now you just more than will be area to the right hand side. So the calculation will be exactly the same, except you subtract from 1, right? So that would be around like a 10.6% gonna lose more than 20 suitcases. Okay, so if you ask the other way, you should still be able to calculate that way. All right, so this you have an answer here. That should be A. Okay, number 21. This is the IQ test. The score normally distributed with the mean of 100. Standard deviation is 15. Find the probability that a number at a random is from the shaded area of the graph. So what does this one mean? This one is giving you the x value in here. So this is reading the x value is 110. Okay, and then you want to find the probability. Remember, if you want to find a probability, you will need to find a G-score and go to read the table, right? So very straightforward. I need to find a G-score. All right, and this just reading the x here is 110 minus the mean here is 100. Okay, so we have a 10 over 5. So if you calculate this one right here, this will be 0.666. So so I round to 2 decimal points. So this is around 0.067, and this is the area to the left. This is area to the left. Okay, so I will just need to read the table, and that's it. That's the answer. Read the table. 0.67, 0.67. This is giving you 0.7486. 0.7486 right here. All right. So if you randomly select one person, about 3/4 of the chance you're gonna have a person the IQ score is less than 110. All right. Okay, this one is called reading table backward. So we want to find a Z-score that giving this area. So this is 0.2810 is the area. And then we're gonna go to find a Z-score in here. Okay, so sometimes in this case, we call reading the table backward. And how do I read the table backward? It's 0.2810, right? So I'm going to look at the area 0.2810 right here, and then trace back the Z-score in here. And then we can see, oh, there's a number here called 0.2810, right? So how much is the Z-score? A Z-score will be negative 0.58 in here. Look at it, negative 0.58. Okay, so that is called reading the table backward. Unfortunately, sometimes when you don't have a number exactly in here, so how about if I want to have a 0.2815, right? And there's no 0.2815 right here on the table. What can you do? You will need to go to compare these two numbers and then choose the closest one. Okay, so sometimes when you read a table, if it doesn't have an exact value on the table, you will have to find the closest one, estimate. All right. Okay, this one is getting a little bit more complicated on the table in here. Find the Z-score of the, which 98% of the distribution area lies between negative Z and positive Z. All right, so I usually recommend you to draw a table in here. Draw a table. When you draw a bell curve. Okay, when you draw a bell curve, everything will become easier. So this one is distribution lies between negative Z and a positive Z. So that means my 98% is in the middle, and the left hand side will be negative Z, right hand side will be positive Z. The good news is this one are symmetric. Bell curve is symmetric. So these two G is the same number, but the left hand side will be negative, right hand side will be positive. Okay, so I will only need to read one time. So since the table is always a corresponding area to the left, so I can go to find this smaller area. So how much is this area? We have a 1 minus 98%, so that will be 2%, right? And then this one will be 1%. This is also 1%. So we need to divide by 2. Okay, 1% here is 0.01. So if I go to read the table here, I will need to find 0.01, 0.01. Okay, and then we're gonna go to look at this one right here. We don't have an exact number of 0.01. We're gonna look at these two numbers to see which one is closer to 0.01. The answer will be this one right here. This one is closer. So this one is negative 2.33. And that is this one right here, negative 2.33. This one will be positive 2.33. So that will be this answer in here. Okay. There's another one right here. You can use the calculator if you don't want to estimate. Let me show you the calculator a little bit. Reading the table backward, you can use the calculator. Go to second vast distribution, and then using number 3 called inverse norm. As long as I type the area to the left 0.01, and I hit enter, and then I run to 2 decimal point, I got exactly the same number as negative 2.33. If I run to the 2 decimal point.
What did you just press? Second what?
This is a quick, easy way to read the table backward. All right, so let me show you one more time. Second VARS, which is I'm gonna use the distribution in here. Okay, second, all right, how to get this one? Second VARS, and then go to number 3, inverse norm, and then just type a 0.01, and hit enter. And that is the inverse normal distribution is the G-score. So that's negative 2.33. Sometimes people find this way is much faster, easier to find a G-score than reading the table. Okay. And if I want to read a positive one on the right-hand side, I will have to use the entire area. Look at it. If I want to read this positive G-score, I will have to use the area, this whole area to the left, because that is how they're corresponding to. And then this will be 0.99, right? We have 1% plus 98%, that's 0.99. So if I go to read a table using second bus, using inverse norm, if I type a 0.99, I should get exactly the same number but positive one. Look at it. So I don't have to do that twice. If I know that, I just need to read it once, and I know this side will be positive. So that will make it easier that way. Okay. All right. Another question here is 24. Find a G-score corresponding to the 30th percentile. So now you need to understand, what does the 30th percentile mean? 30th percentile, that means is area, the entire area to the left is 30%. And then how much is the G-score here? Okay, and I will need to convert this one into decimal point, which is 0.30. And if you want to go to read this table, usually not quite exactly, you will have to go to find a 0.3, 0.3, right? So 0.3 somewhere right here, 0.3. I'm going to read a 0.3. Now you will need to go to compare these two, because I don't have a 0.3000 exactly in here. Now you will need to compare these two. Which one is closer? If you use this one, you have a 0.0015 actual. If you use this one, there's a 0.0019 different. So I'm gonna have to use this one closer. So that's negative 0.52. Okay, and look at this one right here. If I use the calculator, which is much easier, I don't have to compare, right? I will just hit 0.30 in, and I round to 2 decimal point, and this is 4, so I round down, so I have a negative 0.2, because we all, for the G-score, we always only keep 2 decimal points. So that is exactly the same in a much quicker way in here. Okay? Any questions? All right, number 25 is you want to find the x-score in here. Remember, we have a g is equal to x minus mu over sigma. If I multiply both sides by sigma in here, we have a x minus mu. So if I add a mu on both sides in here, we have a formula is x equal to mu plus g times sigma. The good news is this one. If you look at the formula sheet here, we also have a x formula for you in this case in chapter 5 already. Look at it. If you want to find the x value, we also giving you the x equal to mu plus g times sigma. So this one is in the formula sheet. But I want to show you is this formula and the G-score formula actually is the same. All right. So if we're giving you the G-score, you can find the x value in here. So mu here is 100. G-score here is negative 1.645 times sigma here is 15. If you go to calculate this one right here, that will giving you 75.3, which is C in here. Okay, so giving you the G-score, you can find the x value in here. Okay, 26, compare the score of 220 test with a mean of 200 with a standard deviation of 21, and a score of the 90 test with a mean of 80, standard deviation of 8. So sometimes people like, do the two tests, right? If you are in high school, you're trying to go to the 4th year, you either have to take the SAT or ACT, two different standard tests. Although there's a rumor says some college, they don't, they don't use the SAT or ACT. They're trying to get rid of standard test, okay? But still, majority of the schools still using both tests. So if you want to know which one you do better, you will have to compare the G-score. Otherwise, the different test has a different total, right? So we're gonna look at the first one right here, and then we're gonna look at the second one, okay? The first one right here, you have a 220 on the test. And then this is 200, standard deviation is 20, 21. Second one here is 90, mean is 80, standard deviation is 8. And then we're gonna go to calculate the G-score, trying to see if you can see this one is less than 1. And then if you look at this one, this is greater than 1. So we know the second test is better, right? Of course, you can convert it into you can calculate into the real number, but if it didn't ask the number, I already know which one they do better, right? I'll just look at this number, 20 divided by 21, that's 0.95. Okay, but if I look at numerator, it's less than the denominator, so I know this will be less than 1, right? This numerator is greater than the denominator, so I know this one will be 1 point something, so I know which one is better. If you want to calculate a real number, you can do that. Okay, that's 1.25. So whatever the G-score higher is better. All right. So that should be the C in here because you have a second test, you have a higher G-score. Okay, and that is better. All right, 27 is very similar, as I mentioned earlier, SAT and ACT score, right? Which one is better? So if we look at the SAT in here, SAT G score, okay, this one is, okay, the student take a score A60 on the ACT, on the SAT, right? And the SAT being is 1026, standard deviation is 209. ACT G score here is 16 on ACT. Okay, and the being here is 20.8, and standard deviation is 4.8. So looks like this student they test both less than the average. So you're gonna have a negative G score. Okay, so A60 minus 1026. Remember to use the parentheses. So this is negative 0.79. Okay. If we run to 2 decimal point, the third digit is 4, so we run it there, right? All right, this is negative 1.0. If you want to add a 2 0 right here. So which one did the student do better? Okay, this one is better, right? Because they both are negative, but this one is a little bit less. The negative, the less negative, sometimes I say the negative is something you owe. The less you owe, the better. Okay, so this one is below the average, but this one is a little bit less below than this one. All right, so the SAT, the student do better. Okay, so when you compare the negative number, you have to be very careful. Okay, 28. Assume the salary of elementary school teacher in US are normally distributed with a mean of 29,000, standard deviation is 2,000. What is the cutoff salary for the teacher in the top 10%? Well, in order to do this one right here, you will need to find a G-score. Okay, so top 10%, that is the area, which is 0.1. And how much is the G-score? Remember, if you want to find a G-score, you will have to use the area to the left. So area to the left here will be 1 minus area to the right. So your area to the left here should be 0.9. So when you go to read this G-score in here, you will need to use the 0.9, otherwise you're gonna get a negative G-score. Okay, so second bars, using the inverse norm, type a 0.9 in here, and you can find a G-score. So that's 1.28. Okay, after I find a G-score in here, remember X will be just mu times G times sigma. Okay, and then if I have a mu here, 1.28 times sigma here is 2000. All right, and now we're giving you 31.60. Okay, so that will be in the top 10% in here. So this one right here is giving you the percentage in here. Remember, the percentage is also the area. Okay, so giving you this 10% area, you will need to be able to find the G-score, and then just using the X value to find the calculation in here. Okay, any questions?
No, ma'am.
All right, okay, so number 29 is very similar. The tire company finds the lifespan of the this one normal distribution with the mean standard deviation. If the manufacturer is willing to replace no more than 10% of the tires. So what does that mean? What does no more than 10%? No more than 10% is less than 10%. So this time is area to the left. So this G-score will be negative 1.25. Remember, we just read the G-score on the top 10% of 1.28. This top 10% is area to the left, to the right. This will be area to the left. Okay, but since I read the G-score earlier, this should be the same. So it's negative 1.28. If you don't, you can just still go to the second bars using the inverse norm. And then if you just type a 0.1 right here, this got a negative value. Okay, so either positive or negative, you have to be very careful in doing that. So this no more than 10% is the less than 10%. That means less than 10%. So your X here is mu times G. And then you just using the mu plus this one is negative. Okay, and then standard deviation is 4,000. Of course, this one you will minus, right? Minus, and then the 2 zeros in here. Okay, just make sure I got it right. Double check. 1.28 times 4. Okay, 112. And that should be another 0 because this got 3 zeros. This only got 2 decimal point, right? And then you subtract this one right here, that will giving you 41680, which is this one in here. Okay, so that is how you do this type of calculation. Basically, you will need to find a G-score and then plug it into the X value in here. Okay, the last section for this chapter here, we are dealing with n is greater than 1. When n is greater than 1, we have a little bit modified G-score, which is x bar minus mu over sigma divided by square root of n. Remember, when we talked that earlier, we always randomly select 1. Okay, randomly select 1 in here. We all dealing with n equal to 1. This time, when n is not equal to 1, we call this the standard error in here. You will need to divide by square root of n. Otherwise, everything else is very similar to the one we have earlier. So assume the height of the women are normally distributed with the mean of this much and the standard deviation. This time, if you select 75 women, find the probability they have a mean height between 63 and 65. So it's 75 women are selected. So that means n is greater than 1, you will need to divide by this one right here. Okay, and then for 30th, you have a between. Of course, between is The bin here is 63.6, and then between 63, so it's on the left, 65 is on the right, so it's find a percentage in here. So this one, you will need to find a 2G score. You will need to convert it into 2G score and then do the area in here. Okay. So the X one here is 63 minus, and then standard deviation here is 2.5, and here is 75. Okay. One thing is very important here is you must use the parentheses when you do the calculation. Otherwise, you're gonna get an error. Okay, so that's the first one. That's the second one, which is very similar. You're using 65. All right, so we can just put these two into the calculator, do the calculation. Okay, one thing is if you want to calculate everything together, denominator, you need a parenthesis as well. Okay, so if you run to 2 decimal point, this will give you negative 2.08 because you have to run this one up. Okay, and then the similar one, you do the second calculation. Remember, this is my calculator, it automatically add a parenthesis, so I have to close them. All right, so this is 4.85. You run the 2 decimal point. Okay, so some people say, well, my table don't read a 4.85. What happened in here? So the probability in between, we're gonna go to using the probability of G2 minus probability of the G1 in here. 4.85 is greater than 3.9. The biggest number we can read from the table here is 3.49. 3.49. So if you have anything more than 3.49, you're gonna just use this number because this is very close to 1 already. You already got a 9 in here. The total area is 9, right? So this is very, very close to 1 already. So we're gonna just use this one right here. 0.9998 minus this one is negative 2.80. Negative 2. I already forgot the number. Negative 2.08. Negative 2.08. 2.08, which is second one right here. So that's 0.0188. All right, so if you go to do the calculation, this will give you 0.9811. So that will be this one right here. Okay, that is how you do this type of calculation. 31, which is very similar, but this time is greater than 122. Okay, greater than is area to the right. All right, when you have a greater than is area on the right hand side. So we need to find the area to the left first, and then you have to go to calculate this G score first. Okay, so X here is 122 minus the bin is 100 divided by sigma here is 8. And then this you choose 100, so N here is 100. So divided by square root of N. This should be a little bit easier to calculate. So this will be just 22. This is square root of 100 is 10. Okay, so basically this is 220 divided by 8 in here. Okay, 20. All right, I get the bin incorrect. Bin here is 120. Okay, remember bin here is at 120, not 100. I got this one wrong. All right, so that's 120. So this we are giving you just 2 only. All right, so that's 20 over 8. Okay, so that's 2.50. 2.50 in here. And remember, this is area to the right. So when I have an area to the right in here, we need to use 1 minus area to the left. So go to read the z-score, 2.50, 2.50 positive, 2.50, the first one. So that's 0.9938. All right, if you subtract this one right here, this will be 62, 0. Okay, yeah, we do have an answer in here. So that is how you do this type of question, okay? So very similar, as long as you have an n greater than 1, just make sure you have a denominator divided by square root of n. Otherwise, the calculation is very, very similar, okay? All right, this one actually is compare n equal to 1 and compare n is not equal to 1. You can go ahead and do your own calculation in here. I think that this will be the answer. This is from the probability, the sample just 1 cut. So we can do that very quickly in here. Look at that, when n equal to 1, square root of n will be 1, right? And then if you have a sigma divided by square root of 1, this is 1, so this will be just a sigma. So you don't, that's why when we have an n equal to 1, we don't have to have this one right here. But this is called a central limit theorem, which is much more general in here. Even n equal to 1, you can still using the same formula, but it just, divided by, you don't have to divide it by 1 in here, okay? So when n is 1 right here, we have a g will be just x bar minus mu over sigma, okay? And all right, so the x here, the bin is 12. Standard deviation here is 0.2. If 9 cut probability less than 12.1, so this area to the left. All right, and then this one, you will have a 0.5, okay? When n is equal to 9 in here, what happened with the g? 12.1, you will have to divide it by square root of 9, okay? And then square root of 9 is 3. All right, so that's 0.3 over 2, that's 1.50. So you go to look at the probability in here. All right, less than, so that's 0.5. 0.5 here is 0.6915. Okay, and when n probability of n is equal to 9, which is less than 12.1 ounce, n is 9. This is also less than 12.1, right? And then this is you just need to read the table because it's less than is area to the left. Okay, and 1.50 is 0.9332. Okay, that's why you got this answer in here. All right, so that is how you do this type of question. Okay, 33 and 34, last 2 questions. If the monthly rent for audio studio apartment in a certain city has a mean of 920, standard deviation of $190, randomly select a size of 30 are drawn from the population. What is the mean of each sample is determined. So what is a central limit theorem? Central limit theorem basically telling you the mu is equal to the mu of x bar. The sigma of the x bar here, so these two are equal. Okay, and then the sigma of the x bar is equal to sigma divided by square root of n. So the mean here, the sample mean is equal to the population mean. So the sample mean here, this mean is 920, so that should be 920. So you have a 920, 920 here. This would be the incorrect one, okay? And so that's 920. And the sample standard error is equal to the population mean, which is standard deviation. Standard deviation divided by square root of n. N here is 30. This is n. All right. And then we just go ahead and calculate this one right here. We have a 190 divided by square root. Okay. That's the square root of 30. And now we're giving you 34.69, right? You round the third one up. Okay, so that is this one right here. So this one is the incorrect one. All right. So that is called using the central limit theorem in here. Last one is pretty much the same. The mean annual income for adult women in a city is this much, and the standard deviation. The distribution of the income is skewed to the right from the mean and the standard error. Okay, so what is skewed to the right is not quite symmetry, right? We have this one earlier. This is called skewed to the right. That's how you look at that in here. But the mean here, the sample mean here is still equal to the population mean. Remember, this is the central limit theorem we talked about. So the mean here is still 285. This is still 28520, right? And this one right here, standard deviation is 5600 divided by square root of n here is 66. So we can just go ahead and do a little bit calculation. Okay, so that's 689.31. Well, this one just wrong to integer in here. So that will be 689 in here. Okay. All right, so that's it. That's all we have for these two chapters. We actually review both of chapter 4 and chapter 5 for all the test review tonight. Okay, so hopefully they help. Next week we're gonna review the chapter 6 and 7, and you know we lost one review session, but basically we actually able to catch up that one. Okay, so any questions? All right, you will need to try to finish test 3 as soon as possible. Okay, this week is end of the February already, and we only have 2 more weeks there. All right, so finish the test 3 this weekend, and then you will have time for the test 4. All right.